Let me introduce Luca from Fairphone, who's going to talk to us about using open source to stop us from throwing our phones away all the time.
Hi. So welcome to my talk, Open Source for Sustainable and Long-Lasting Phones. My name is Luca Weiss. I'm an Android platform engineer at Fairphone. I'm also maintaining a bunch of open source projects, including PostMarketOS, doing some contributions for Linux kernel and OpenRazor. And of course, you can find me on Mastodon. So let's go a bit into what Fairphone is. So Fairphone is a phone manufacturer. We were founded in 2013, kind of as an outcome of an NGO awareness campaign. I will go into this a bit later. Yeah, we do fair electronics. So we have our smartphones, we have some accessories for the smartphones, and also some audio products as of lately. Our head office is in Amsterdam, but we also have some employees in China and in Taiwan. And currently about 140 people are working for us. So, the digital industry. The environmental impacts are not negligible. It's about 4% of the global greenhouse gas emissions, and about 10% of the world's total electricity consumption. And of course, also the digital industry uses a lot of other resources like minerals for production and fresh water, for example, for data centers and production also, of course. And of course, there's social impacts, as we know. So kind of as in greenhouse gas emissions, about 85% of this is actually used for device production. And then 16% is used for example, running the networks and data centers. These numbers are for France, but I guess it's quite similar for a lot of other countries also. Electronic waste, as I think know, is a really big problem in the world right now. It's the world's fastest growing waste stream with over 50 million tons per year. And of that, phones are definitely a big component. About 1.5 billion phones are sold every year. Most of them are not kept for long. They're only kept for 2 to 3 years and then recycled, or probably most of them are not recycled. Some of them are kept in drawers, but for most of them, we actually don't know. Informally, lots of millions of people around the world are working informally to work to dispose of electronic waste, to re-get some of the materials. But for most of them, it's quite hazardous working conditions to both their health and also the environment where they're doing it. Yeah, and only 20% of the devices are actually recycled properly. So what can we do about this? Fairphone itself was started in 2012 as an awareness campaign about conflict minerals, as I said. Was started by Bas van Abel and a few other people. So Bas van Abel was our CEO until I think about 5 years ago. It was a part of the Waag in Amsterdam. It's kind of a tech incubator there. And after a few years of campaigning, they realized it was showing the problems, but it wasn't actually creating any alternatives. So the best way to actually understand it and to influence it was to be part of it. So Fairphone BV was born as a social enterprise with a huge ambition to actually change the electronics industry from the inside out. And here social enterprise means kind of that the financial profitability is just a way to actually achieve a lot of impact in the world. So with no prior experience in the phone industry, a crowdfunding campaign was launched. It was one of the most successful crowdfunding campaigns in the EU for about 10 years. And wasn't done on regular platforms like Kickstarter, but actually on our own website. And so our mission at Fairphone is to establish a viable market for ethical electronics and to motivate the entire industry to act more responsibly. And we were founded really with the purpose of creating a better electronics industry. So let's look a bit at kind of how the timeline of Fairphone was. So as I said, we were founded in 2013. We launched our first phone there. In 2015, we launched the second phone, the first ever modular phone, where you could actually very easily replace parts without actually needing a screwdriver for some of the parts. In 2016, we published an open source Android version that for Fairphone 2 that we maintained. For example, in 2018, we got into a partnership with Orange, so kind of the start of the of some business relationships with network operators, so you can actually get the phones from operators. Fairphone 3 was launched in 2019. Fairphone 3 Plus was launched a year later, which was kind of the same phone but with upgraded modules. So even if you had a Fairphone 3, you could just upgrade the camera modules, and then you basically had a Fairphone 3 Plus with better camera quality. Fairphone 4 was launched 2021. This year we launched the FairBuds XL, our headphones, and the Fairphone 5 was launched about 2 months ago. Yeah, and we celebrated our 10-year anniversary earlier this year. So our nice smartphones, as you can see, they're also growing a bit bigger, not too much lately. For example, we can look at Fairphone 2. We actually managed to get software support between 2015 when it launched and earlier this year, 2023. So we got 7 years of software support for this device with 4 major Android version upgrades. It was launched with Android 5 and we had Android 10 in the end. With Fairphone 3, so far we got 3 major upgrades for the device, and we are guaranteeing updates until at least 2026. Fairphone 4, also at least 2026, but we're aiming for 2028 to actually support the device. And the Fairphone 5, we're actually managing, or hopefully managing, to at least get software updates until 2031. So 8 years after launch, but we're aiming for 2033, which is 10 years after launch, which is would be a great milestone to have. As I said, this year we also launched our FairBuds XL, our headphones. I think they're quite nice. But yeah, the Fairphone 5, our slogan is kind of designed for you, made fair. It is designed with care to be fair to you, fair to the people and to the planet. And it's built to last longer, to be able that you use it longer, so it's also better for the planet. So let's go a bit into the first part of our tagline. So 10 years of software support, what we're doing with Fairphone 5. This is mostly enabled through our use of a kind of special chipset. It's an IoT chipset that is actually used in the phone, or a long life chipset. But it's quite similar to other Snapdragon processors in there. So we're getting a lot of support from Qualcomm there. So at least until 2031, we will get updates, hopefully 2033, with probably Android 19 or whatever it will be called by then. Who knows? So you may ask, why do we have so long software support for the device? Because a lot of people are actually changing their phone because of a lack of software support. And of course, also if you don't update the device, hopefully I don't need to tell you, but if you don't update the device, no issues can be addressed, no security vulnerabilities that are always discovered can be patched. And of course, you also don't get any new features, which may, for example, come with new Android versions. So, for example, there are better permission management, autofill functionality, etc. I hope you know, or I guess you know, that Android itself, or the thing called AUSP, is open source, Android open source project. But what is actually running on the phone in the end is not really just AUSP. There's a lot of other things running on the just on the main CPU here. And a lot of the, so for example, if we look up here, so the Android apps you can get from the Play Store, they're probably also all proprietary, except if you go through F-Droid or something. The Android framework, Android API, etc., they are open source, they're part of AUSP. Also the system services in Android runtime is open source, it is part of AUSP. But once we go a bit lower to the HAL and the native daemons and libraries, these are provided by the SoC manufacturer, and they are usually very proprietary, so nobody apart from people with an NDA or a special business relationship with Qualcomm can look at them. And on the bottom we have the Linux kernel, which is open source because it's GPL licensed. So I was talking about the code that goes into Android itself, but also what's running. So Android itself kind of would go into the main CPU of the device, so kind of where Linux is running. This is getting code sources from AUSP. For Qualcomm, it goes via a platform called Colinaro, previously called Code Aurora Forum, CUF. You've probably heard, or you maybe heard of it. Also some proprietary code goes in there, but a lot of proprietary code is also needed for for many other parts of the SoC. So, for example, a lot of the coprocessors on the device, for example, for modem, for some audio handling, etc. They're all proprietary, and these are also very much needed to be able to run a phone as you would expect. So now let's have a look at what this means for on Android. Bringing Android to the device is quite a complex process. So any new Android release starts out at AOSP from Google. The version gets released, then the SoC vendor takes the AOSP code, adapts the code to a specific SoC. So writing all the hardware abstraction layer, etc. Once the SoC manufacturer is done, then the device manufacturer gets this. They can integrate their changes into the code. So, for example, for specific touchscreen support or other specific support, or some UI changes that need to be done, including also adding some operator changes on top. Then the operator requirements need to get tested and also integrated, and a lot of things need to be adjusted there to actually work properly. And then finally, the Android version or the specific Android build needs to get launch approval by both Google, but also the operators to be able to launch the version. For normal updates, so both security updates and regular maintenance updates, from there every month, both Google and Qualcomm and some other parties are releasing security patches. These need to be integrated by the device manufacturer, but also, for example, network operators have, for example, updated requirements or new app versions that also need to be integrated. This all needs to come together, and after a security update is ready by the device manufacturer, it still again needs to be approved by by both Google and the network operators to be able to launch it. Google maintains any Android version for about 3 years. So then either you need to upgrade to a new device or to a new Android version, or you need to stop support, basically. Hopefully you're also upgrading before the support runs out, so that you get the new Android versions already. But yeah, what happens if this chain is broken? What if the SoC manufacturer doesn't provide compatibility for a new Android version for the device anymore? Well, that's generally where software support in the industry is stopping. Because the device manufacturers don't get compatibility anymore. So let's look a bit about our wonderful device Fairphone 2. As I said, it was released in 2015 with Android 5, sorry. In 2016, it got an Android 6 upgrade, and already back then, the SoC went end of life. And this is also where other phones with the same SoC didn't have any support anymore, for example, the Nexus 5. However, still in 2018, we managed to get an Android 7 upgrade out, in 2021, Android 9 upgrade, and in 2022, an Android 10 upgrade. So to understand how we achieved this, we actually need to go a bit, dig a bit deeper. So we kind of took over the role of Qualcomm. So we made the SoC work with the new Android version, so in this case, Android 7. For this, we reused a bunch of the proprietary components from Android 6. But we also looked a lot at other SoCs from Qualcomm that got the new Android version, so just new SoCs. So for example, for the Snapdragon 835, we looked at the code there because it was reasonably similar to the SoC in the Fairphone 2. But we also looked a lot at the code from that is in LineageOS. That's not really just taking entire parts over, but it's also about having a kind of a reference to how the device would be working. From LineageOS, we also took a bunch of fixes that fix user-facing issues, for example. So maybe some app crashes, or maybe some app doesn't really work the way it should be. Obviously, it's not an ideal solution because the SoC manufacturer probably can do a bit more in-depth development to get it working a bit better. But it worked quite well. And yeah, we managed to do this for the next couple of Android versions also. We do publish a lot of what we do on our website code.fairphone.com. All of our devices also have, for example, an unlockable bootloader. we do publish as much as we can on code.fairphone.com, including build instructions. So, for example, for Fairphone 3, our device from 2019, you can actually download the Android source code that is being used for the builds that we ship. And you can actually build it yourself for the most part. There will be some differences. For example, there won't be Google Apps included. There won't be Widevine, so the DRM included. But for the most part, it is the same Android source code that we use to build the normal releases. So our phones are easy to repair, but why should it be repairable? Why? Well, if things break on a phone, and they do often break, you don't need to replace the whole phone. If the screen breaks, just can replace the screen. If the camera breaks, just replace the camera. And of course, also batteries, lithium-ion batteries in phones, they're not really made to last forever. Their average or the supposed lifespan is for about 2 years, and afterwards the battery performance just degrades. So if you can just replace the battery, the battery works very well again. And by not replacing the whole phone, of course, you're preventing a lot of CO2 emissions if you don't replace everything. Because really, a lot of the CO2 equivalents that are emitted during device production, most of it goes into the core modules. That's how we call kind of the main PCB with the main processors and a lot of the main components in there. As you can see, then second is mid-housing, which is already a tiny chunk comparatively. So, for example, if you want to replace the battery, you don't need to replace everything. You can just replace battery, and the rest you can keep because, yeah, it's not broken. And this also means if you, for example, if the display breaks and you replace the display, and instead of buying a new phone and you're keeping your existing phone for about 33 days longer, then you're already kind of compensated for replacing the display. So if you then use it 2 years longer, it is really great. So, circular economy, it's a complicated topic, but I try to make it a bit understandable here. But yeah, there's a lot of priorities in there. Of course, Fairphone mostly looks at kind of the produce and the reuse sections here. So kind of during production, it's kind of refusing. So do you actually need a new phone? Maybe you don't. Rethink, maybe do it a bit differently, or reducing, just make it less. During reuse also, we can do a lot of repair, so to not have to produce a new phone, but just repair it. We can refurbish it. If there's something a bit more broken with it, we can remanufacture, or even repurpose it. And at the end of the life cycle of a device, some parts go to waste, some parts just can't be recycled. But some parts we can recycle again and we can put back into the production cycle. But since we can't recycle everything, we always need to have new raw materials because recycling can't just cover everything that we need. So we also do have schematics published for the Fairphone 4, Fairphone 5 hopefully soon. So you can kind of see where all the internal components are connected, including kind of where they are on the boards, on the PCB. It can be quite useful for repair also, and also for software bring up, if you want to do some extra tinkering with your device. All of our the Fairphone 4 and the Fairphone 5 are also covered by a 5-year warranty, because we think that that our devices will last that long, and we want you to also keep the devices as long. So if something breaks after 4 years, we still want you to keep the phone for longer. Because, as we went into getting a new device just causes a lot more CO2 emissions compared to when you just repair it. So let's go a bit more into the made fair section. So we do have in a phone, there's over 50 materials. And of those, at Fairphone, we selected about 14 focus materials where we think that the biggest impact is, or where we can achieve the biggest impact. It's a lot of work to actually integrate these into the supply chain. But as you can see, for example, for the battery, we have a lot of fair materials in there. So fair lithium, cobalt, gold, silver, tins, and some a few less percentage for some other components in there. So for a lot of the components, we are looking to really get a lot of these into our phone. As also, you may ask why we selected these 14 focus materials. We actually published this on our website in our fair materials sourcing roadmap. And this is an excerpt from it. So there's a lot of different factors that go into why we choose certain materials. So you can see here, it's kind of the demand in the electronic sector, critical for functionality, and the presence in phone. There's one of the sections where it's more or less depending on which material. Also been in the social areas, so kind of the government structures in the where it's mined, social challenges, environmental challenges, and also then kind of how we expect the demand to grow over the next years, depletion, how much of it is still available in the ground, and also how much new material do we need to produce the phone here. So to get fair materials into products is kind of 4 steps that we do: research, engage and trace, build and integrate. And we don't really get to the next step before actually finishing and understanding the previous step. So for example, for research, as I showed in the last slide, kind of we have this fair materials source roadmap where we see where we can actually create positive change for it. We engage with the supply chain, actually map the supply chain, engage with key suppliers, find out where they source the materials from, try to get our, already find out how we could possibly get fair materials into it instead. Build, kind of we need to look how we can, if there's already a supply chain set up, if we need to create a new one, if we can collaborate with some other people in the industry to get this done. We integrate, so we try to kind of connect the 2 different sides. So get the manufacturers to actually integrate the fair materials into the product. There's also a lot of it's a continuous improvement. We're always looking into kind of where we need to adjust, where we need to do more. So this is kind of a very rough overview of kind of how a mineral ends up in a product. It's a lot of steps and a lot of in-betweens. So kind of, we cannot just rely on the final assembly manufacturer, so the company that actually puts everything together, where we actually order the product from, basically. Because we can't just rely on them to say, yes, everything's fine, don't worry about it. We actually need to check kind of on each level ourselves to know that it's actually done good. So kind of there's a lot of different component manufacturers and different distributors where a lot of components go through. If you go down, the materials go to lots of traders, to smelters and refiners, and through more traders until you're kind of down where the actual mineral is getting dug out of the ground. So we do map the journey of our materials, and we publish this also on our website. Also, kind of, you may ask, why are we doing this? First of all, because we want to scale our fair sources, so we want to get more of these into our products. But also because we want to have followers. We want other companies to look at this, see how we are doing it, and actually follow it and implement it for their own products. Because, we are just a small phone manufacturer. But if we can get bigger manufacturers to also do the same thing, of course, it will have a lot more positive impact on the world. So, for example, here you can see a part of the supply chain for the Fairphone 4. So you can see the different products that are coming from different areas of the world, coming through different, the smelters and refiners or some manufacturers, and then kind of finally landing in China at our final assembly manufacturer. So you can see, for example, tungsten is coming from some place in Rwanda in Africa. Then it goes through a smelter, I think, in Austria. And then it goes to a different manufacturer in China, and then finally lands at the final assembly manufacturer, so where the actual phone is put together in the end. We have a very long list of all our suppliers, smelters, and refiners on the website, where you can see which companies are kind of involved there. So we want to be fair to people, of course. So we want the highest standards for good working conditions. We have a living wage program, which I will talk about next. But of course, also in the mines, we want to have, for example, fair trade gold, fair tungsten, or lithium from an IRMA audited mine site, which is the Initiative for Responsible Mining Assurance. We want to, of course, make sure that people there are not being exploited, that they actually get paid decently. For factories, I said, we produce the phones in China. China is the largest producer of smartphones in the world. Of course, also a lot of Chinese brands are producing there, like Huawei, Xiaomi, Meizu, etc. But also a lot of other manufacturers have their phones produced there. One of the reasons is, of course, the workers in the factory have different salary expectations to, for example, in Europe. But also many of the materials that are actually in the product do come from China. So we choose our production partners and component manufacturers and the final assembly manufacturer, not just by the technological requirements, but also look a lot of into the willingness to work on the social and environmental issues, and also the willingness to actually improve the working conditions for the employees in the factories. And this is also important because, for example, there's no unions for factory workers in China. So based on discussions with workers in the factories, we defined the need to work on about 46 improvements. Most of them are in the category of workers and worker satisfaction, but also health and safety and worker representation and living wage are part of this. 2 years ago, we were only looking at 16 improvements. So by now, we over tripled the focus areas for this. I was mentioning living wage a couple of times, but what does this actually mean? The living wage is kind of the amount of money that needs to be earned by a worker without overtime to actually have a decent wage to ensure a good living and working conditions. And the living wage gap, which is here, is kind of the gap between the daily wage if they would work 8 hours versus the living wage. So you can see it's actually quite a big gap. A lot of the factory workers are working overtime to actually themselves earn a bit more money to ensure, a good life. At Fairphone, we pay the gap of the living wage for the working hours that are getting spent on Fairphone devices. And actually, this bonus doesn't just get paid to the people on the Fairphone production line. So normal factories, there's a lot of different production lines for different companies. But based on discussions with the workers there, they actually decided that it's fairer that this bonus gets split across all of the people in the company, because otherwise some workers would be kind of advantaged if they work on the Fairphone production line versus a different production line, even though they're technically doing the same thing. For this, in the end, it's only about $2 per phone, which is really nothing if you think a phone is 500, 600, 700 euros, or even more. If you buy a $2,000 phone, what is $2? And you by doing this, you're actually ensuring that the people working in the factory actually have a decent salary. And so we think a lot of different companies should also follow the same approach and actually implement this. Because kind of what we can pay to the factories is just a small part of what would be if every company in this factory would actually pay this living wage bonus. So our phones are made climate conscious. Lately a lot of companies are always using the term CO2 neutral or whatever. But we also don't want to pretend that a phone could be CO2 neutral, because it can't be, at least not yet. We definitely do try to reduce the footprints during device production, and everything else. And we do invest in carbon reduction products, because we do think they at least do something. The emissions that we're covering there, so not just CO2, is based on a life cycle analysis, which is an ISO standard. So for our Fairphones, the Fraunhofer Institute in Germany, they do this They do this analysis for our devices, so we can actually see very detailed kind of where the emissions are and how out of the life cycle is there. We also have this public, and we also think a lot of all of the other manufacturers will also publish this life cycle analysis for their devices, because it really gives an insight into kind of what emissions your device is having. Is this your drawer on the right side? I think it is, because in Europe there's about 700 million phones just sitting in drawers doing nothing. This is more than 3 times the annual smartphone sales. And this of course also means these phones are not recycled. They're just sitting around. They're being e-waste. And this is actually a big part of where e-waste is. So yeah, of course, every time we sell a phone, also we at Fairphone, we produce future e-waste. But for most of it, we don't actually know where it ends up at. 54% of it, it is not known where it lands. Only 17% is actually formally recycled, and about 28% is either 8% is going to household bin, which is obviously not recycling, or 20% are illegally exported to places like Africa. Yeah, maybe you've heard of a place called Akpo Bloshi, which is next to Accra, the capital of Ghana. There were some documentaries about this place. A lot of either e-waste lands there. A lot of people, mostly teenagers, are working there informally, and for example, burning some cables to actually get the copper out of the cables again. Of course, this is a huge health and environmental hazard, but yeah, unfortunately, this is what is happening in the world. So, of course, we do think formal recycling is better. So we've introduced, I think, 1 or 2 years ago, our reuse and recycle program. You can actually get a voucher if you send in your old phone, depending on how well it still works, or how much kind of recycling value could come out of it. You can send any phone, or not. You can send a lot of other phones than not just Fairphone. If you send a Fairphone that you don't use anymore, that's in good condition, it will actually get refurbished, or some spare parts get used for actually getting them back into usage, kind of what I showed before with the circular economy. And of course, this also made it quite a bit easier with the modular design that we have at Fairphone. So yeah, you can just replace, or for example, take the camera if it works, refurbish that one maybe, and then yeah, we have it. So open source software, as the title says, of course, we are using a lot of open source software. So how does it help Fairphone? Well, of course, as I said, the base of the software that is running on the phones is open source, so AOSP and the Linux kernel. We also do pick patches, for example, from Lineage, what I said. So kind of having a good reference also of how things work. Also, the way Android is being developed, it is sometimes a bit difficult to kind of find one code base which is actually working correctly, because the AOSP, AOSP has a lot of different release tags, and a lot of different manufacturers are just picking patches or maybe not submitting them. So Lineage is always working quite well. So it's actually a great reference for this. We do use stable kernel updates, so the LTS kernel from kernel.org where possible. And for example, also we have some automated testing running using Android Test Station, which is an open source project by Google. So, but of course, we are also contributing to open source software. So yeah, of course, with the GPL license, we publish our kernel sources. We also do have build instructions for those, so you can easily build them. We do publish device resources. This is a bit more tricky in recent years because it is normally part of the proprietary package from Qualcomm, so we were not allowed to publish them, but we got an extra, after a lot of back and forth, we got the permission from Qualcomm to actually publish those also, because it's quite important to have these also available if you want to fix some things or just maintain have the community work on this also if they want. We do a factory package on the support page. Of course, these are not open source, but they are quite helpful for third-party ROMs that are trying to make the software work. We do publish the full Android source trees where possible. So we do have quite a bit differentiation. So for Phathom 2 and Phathom 3, they're actually the complete Android source trees, which you can build and run on your device. Also lately we've published some source trees for currently Phathom 4 and Phathom 5, which are not buildable by a user because it is basically the code that our ODM, so the company that's maintaining the Android software for about the first 2 years of the lifetime, and also doing the initial bring up. But there we still want to publish these sources because they can be quite useful. For example, for Ubuntu Touch, if they want to fix something in the audio HAR, that they can actually look at the code and actually patch it and build it themselves. We do have TWP support for the devices. So, for example, for Phathom 5, we were able to publish this on day 1 of release. And I'm also working on kind of getting this officially supported on, so you can just go to the twop.me site and download it. We do have EOS on our web shop. EOS is a privacy-focused Android distro. Where we have a partnership with them. So any end user can actually go to our website and buy it directly from us, and get it pre-installed, shipped to their door. Of course, the normal software that we ship with phones is the kind of the regular Android software with Google services and everything that kind of a general consumer expects there. But of course, we know that some people don't want Google services, so we're actually trying to make it easier for them to run Android without Google services there. And we're also trying to support where possible third-party developers. So, for example, for Calyx OS or EOD OS or EOS, as I said. So I've been mentioning the Linux kernel a lot. So let's talk about let's talk a bit more about it. Kind of the Linux kernel is developed in upstream as the mainline kernel or upstream kernel on kernel.org. This is kind of what most of you are running on your computers, or at least based on this with some extra patches, for example, from Canonical for Ubuntu. Every year, one of these versions gets selected as LTS version, so long-term support version. Based on this, then Google creates an Android common kernel branch from it. So, for example, an Android 11 5.4 branch, which is 5.4 kernel version, meant for devices launching with Android 11. Then kind of similar to kind of how the Android bring up works, what I covered before, the SoC manufacturer takes this kernel version, builds their SoC support on top of that kernel version, and only then the device manufacturer gets this version and can build their support on top. So this also means by the time a device launches, the kernel version is multiple years old. And since it's never really updated, so the SoC manufacturer normally just provides one kernel version and is doing minor updates to that, but not really rebasing their whole tree on a new LTS version. So your A device is normally stuck with the kernel version that it launches with. So for example, you can see here for our different devices, so Phathom 3, Phathom 4, Phathom 5, they have launched with different kernel versions. So even though it says Linux 4.9 for Phathom 3, it's actually about 2.5 million lines of code difference to what is actually being released upstream at kernel.org. It's about about 18,000 commits. So you can imagine taking all of these lines of code or these commits and rebasing them on a new Android or a new kernel version is kind of impossible. And the kernel version for Phathom 3 was released in December 2016, but the device was actually only released in 2019, so it was already kind of 3 years old by the time the device was launched. And also the 4.9 kernel version is, in LTS terms on kernel.org, is end of life since January 2023, so we can't pick the patches from kernel.org anymore, and we have to do this ourselves. Also, it's really getting a problem because, for example, this 4.9 kernel, it is supported still by Android 13, even though also at the beginning it was a bit unclear if it was actually supported. But for Android 14, Google is quite explicit that 4.9 kernel version is not supported anymore. So yeah, we are having a kind of a problem getting to Android 14. We are having some ways to maybe still get to Android 14, but yeah, it is becoming a problem for us. Yeah, for our new devices, you can see the lines of code and the commits, they get reduced a bit. But for example, also, yeah, Pfeffern 4, the kernel version will be end of life in 1 year. So yeah, if we want to go beyond it, which we want to be, where we want to go, yeah, it will be a bit problematic to some extent. And even Pfeffern 5, which launched with kernel version 5.4, we're now at 6.6. So yeah, it is by now kind of 4 years old and will only be supported for two more years, at least this kernel version. Also, all of these kind of lines of code and commit stats, they are without some external kernel modules, which by later devices is actually quite a lot. So a lot of these tech pack components or Wi-Fi driver, etc. So yeah, as I showed, kind of staying on old kernel version is not a good idea, because yeah, support will be dropped by AOSP. There is, of course, if you're staying on the same version, there will be no new features or any improvements. And yeah, if maybe there's also questionable if there might be some extra security issues if you stay on a very old kernel version. So yeah, what's the alternative? Yeah, we can try to push device support upstream into mainline kernel, so we can hopefully easily upgrade the kernel. So it's kind of an R&D project that we have. Example Pfeffern 5, our newest device. It's now about 2 months after launch. And with the kernel version 6.6, so the very newest kernel version, plus about 100 patches only, we get a lot of the functionality already just working. So, of course, yeah, a lot of the basics, serial console, power buttons, volume buttons, regulators, real-time clock, they're all working. USB is working, including Type-C functionality, so you can, for example, plug in a USB keyboard and it actually gets detected properly. Internal storage and SD card. Display is working, touchscreen, and the GPU is working with the open source FreeDrano driver, which is in Mesa. DisplayPort over USB-C is working, so you can already plug in your phone to a monitor, and you can use the monitor as a second display for the phone. Wi-Fi and Bluetooth is working, battery and charger state is working, hardware accelerated video decoding and encoding is working. All of the co-processors are up, so all of these are running Science proprietary firmware, but we can start the processes and actually talk to them, so they do the correct things, for example, the modem or the ADSPs for audio and a few other things. Flash and torch LED is working, and the camera I2C bus is working. So we can at least currently talk to the camera sensors via I2C. We can't get any image data yet from it. But of course, a lot of functionality is still missing to actually have this fully functional and be at least remotely ready to be actually used by normal end users. So yeah, the modem is actually not working really yet. This might just be an open source user space issue. I haven't really gotten to the bottom of that yet. Audio is not working yet. Didn't really spend any time on this yet. Camera is missing. As I said, we can talk to the camera sensors, but we can't get any picture data from it yet. Time of flight sensor, which is kind of a distance sensor for autofocus. Vibration motor, NFC, and sensors are also not working. It's also kind of good to know here, for example, the camera stack works quite a bit differently, kind of what mainline Linux would expect. So where you get some video for Linux devices, you open them, you maybe run some IOCTLs on it, and then you get some image data from it. In Qualcomm's Android stack, this is actually implemented in user space. So basically all of the sensor communication via I2C happens in user space. And yeah, a lot of different functionalities implemented there. Replicating this kind of in a completely open source way is probably kind of impossible, or at least getting the same amount of image or the same quality of image from it. But still something, yeah, we are interested in looking at kind of how much we could do there. As I said, this is all an R&D project. So yeah, we are exploring different ways to kind of resolve this problem that we have by having old kernels shipped by the SoC manufacturer to us, and kind of how we can resolve that. For Android versions, we have figured this out with Phev 2 already. How to kind of get away from the SoC manufacturer's dependency on updating to a new version, but for the kernel we haven't figured it out yet. We're working on that. We're also looking into a few different parts of maybe how to get to a newer kernel version, maybe differently to kind of what a pure mainline upstream kernel would be. But yeah, unfortunately we don't have something to share yet. Maybe at some point. Yeah, so I think at least for the Phev 5, I think we got quite some reviews. We are quite happy about what we were able to do with it. Media seems to be positive. Lots of great reviews. So thank you for listening, and time for questions.
Thank you for the detailed presentation. I wanted to ask, in order for you to become sustainable, you also have to be economically sustainable, so that you can keep producing parts and support. How do you even, because you seem to be working against capitalism, within capitalism, how do you make that work?
So we generally the kind of the financial goal of the company is to make a profit, not really just to please investors, but to just to stay alive. Because of course, if you're just making miners, you can't stay alive. Except if some, for example, venture capital firms are always pumping money into the company. So we're definitely trying to be financially healthy there. I think was it last year or 2 years ago or something? You can read this in our impact report, I think it's called. So we actually did make a profit. So it is tricky to balance everything, of course. But yeah, for the detailed numbers, you can really check our impact report where a lot of the numbers are, and you can hopefully find an answer there.
Just a comment was around the time of the Fairphone 4, I kept noticing that you had a LCD screen, and once you've kind of experienced an OLED screen, you kind of don't want to go back. So I was like, oh, I wish Fairphone would come up with an OLED screen. And literally about a month before you announced the Fairphone 5, I went and purchase another phone, and I was like, no, now I have an OLED screen. So anyway, my question is, when you say you can donate old devices, I mean pretty much any device, if it's an old like Nokia 3310 or something lying in the drawer, or would you be able to donate those kind of devices?
So for the reuse and recycle program, we do have a list of devices that you can send in. I don't know the details there. You can check the website. It's not every device, so you can't just take any random Chinese phone and send it there. But I think a lot of devices are on this list, so especially ones that were sold a lot in Europe, I guess.
You shared a lot of what you're doing to keep your phones updated to the current software versions and the kernel as well. How much of overhead are you incurring just by coordinating with other vendors like Qualcomm for the chipset and Google for Android? That would be eliminated if you would own your own mobile software stack and chipset.
Yes, but I mean, of course, it's a lot less work to make existing software work for the devices. It's also kind of my job to kind of figure out why the software that is being provided to us by either directly Google or Qualcomm, why it doesn't work. Of course, we will have different problems, and I think a lot more work to have our own operating system. And of course, also in the mobile landscape, it's kind of impossible to really have any even Android-based alternative without Google services is kind of impossible. I think Huawei tried this with their Huawei mobile services, and I think they pumped a lot of money into it, and I don't think it really went anywhere in Europe, at least. So yeah, it is difficult. Of course, with EOS and the web shop, we do provide a variant without Google services provided there. It is, of course, for people that actually want this and only want the open source software that doesn't have any Google service reliance. Yeah.
So what would you say is the excuse that we have? Sorry, hi Luca. Why wouldn't my next phone be a Fairphone, and what would it take to get over that hump? Like what's the catch? Let's just maybe say this. Like, what do you think is the most important things to fix so that all of us here are comfortable with this being our next phone? Because all of the things that you said are great, right? So let's get there.
I mean, I would ask you why you don't have a Fairphone. I mean, of course, I know that a lot of people get their phones through operator contracts, and a lot of operators we don't collaborate with, so you can't get it through the operators there. Of course, also our phones are quite a bit more expensive compared to other phones of the same kind of technological specs. But yeah, we're not just doing technological specs; we're also doing the fair specs and trying to get a lot there. So unfortunately, we are not pocketing a lot of profit. Would be nice. So it actually does cost us quite a lot to actually get out of this running. If we were to sell more devices, probably economies of scale would also help to make it cheaper there and to make it more affordable for people. But yeah, it's a very tricky thing there.
So you showed the list of your priorities, and the purpose was very, very low. And this is a bit weird to me, because a 10-year-old phone is a very underpowered phone, but a very powerful thermostat, for example. So are you doing something about that? And why is it such a low priority, given the potential impact is very big from this? Thank you.
So I think from Fairphone's perspective only, I mean, this is tricky. I mean, so far the devices that became end of life, so kind of Fairphone 2 by now. Fairphone 1 is a bit of a different story. Fairphone 2, there's actually a company looking into kind of, or researching kind of what could be done with the old main boards, and maybe getting them into kind of IoT devices or repurposing for something proper. But of course, also before, it's kind of the question, when would you start making kind of an alternative use case from a company? So for example, I don't know, maybe after 5 years after launch, we make a kind of what the framework talk was. So kind of making a desktop enclosure, let's say, for the tiny phone SoC, and being able to connect a monitor to it and everything, using it as a desktop, which probably would work even worse because it's an old underpowered phone. But something like that. But maybe a lot of people have already kind of thrown the phone away or given it to someone else. So I think it's a lot easier there to just give other people the phone and to reuse it, to actually use it longer. After 10 years, I think, yeah, it is tricky to say also because we don't really know what will be the performance requirements be in 10 years for kind of running anything. Also think the kind of form factor wise, it might be tricky to, especially some of our phones kind of have a phone shaped SoC. So they're just a bit too bulky and weird to actually put into something.
You shared that your company has venture capital investment. How do you ensure that the company stays true to its mission in 10 years, 20 years down the road with investment?
So we, I don't think you can classify what we have as investments as venture capital. We do have some investors. I think earlier this year, we closed another funding round with a lot of investors or some investors. So the kind of the mission of Fairphone is being overlooked by our supervisory board. So we do have someone, and also when getting new investors on board, we also look at them to see what are their goals. Is it just to make money or to actually do something proper with it? So for example, I think there's InvestNL is one of the, I think it's kind of part of the Dutch government that has some investments in us, and I think some other parts also. I think you can find more about this earlier this year. There should be, if you put in like Fairphone investment round, I think it was about 40 million or something around this number. I think you can find some of the names there. But we definitely do look at also the investors that invest in us and make sure that they don't want us to do weird things.
Hi. Any plans to give an e-ink display a try? Thank you.
I would say no. I think there were a few phone manufacturers in the past that tried to have either like as main display or as kind of a secondary display on the back. I think there was a company, I think a Russian company 10 years ago or something. I don't think it really works. And I think, as you can see from our phones, we're not really very experimental in kind of the phones that we do. We kind of try to do something that we know that will work. And will also sell, because yeah, of course, if we produce a lot of phones or design a lot of phones, which costs a lot of money, of course, and don't sell anything, yeah, we will go bankrupt and yeah, we will stop to exist. Yeah, I think also, I guess, for example, I don't know, if you look at folding phones right now, you can see there's no Fairphone folding phone. I don't think we'll have one anytime soon, because there's a lot of concerns with kind of how the hinges work, how the durability would be. If we want to have people keep the phone for 10 years, I'm not sure any current folding phone will actually last for 10 years. And if it's the first phone, then of course also more, or the first phone that we designed might also be extra problems.
I want to say thanks to Luca, and also especially thanks to Fairphone. I think they've had a bigger impact on the industry than just the number of phones they sell. And it's really, really admirable. All right.
Thank you.